Have you ever pondered why certain substances seem to have a stronger addictive pull than others? It's a fascinating question, and the answer lies within the intricate workings of our brain. Addiction, you see, is a neurological process. When we ingest a substance, it doesn't simply disappear into our bodies. Instead, it interacts with our brain in complex and often profound ways. Different substances affect the brain differently, and the impact can vary widely, from subtle changes in mood to dramatic alterations in perception. This all happens through a vast network of brain circuits, each playing a unique role in the experience of addiction. Think of these circuits as the brain's communication system. They're the superhighways of information, dictating how we feel, think, and behave. And when it comes to addiction, some highways are more heavily traveled than others. Understanding the brain circuits involved in addiction is the key to unlocking the mysteries of why some substances are more addictive than others. So, what exactly is this salience network we keep mentioning? Well, imagine your brain as a bustling city. The salience network is like a vigilant traffic controller, directing the flow of information and deciding which signals deserve immediate attention. In essence, it's the brain's way of prioritizing what's important and what's not. Now let's bring addiction into the picture. Imagine a drug as a loud, flashy sports car zooming through the city. The salience network, as our traffic controller, can't help but notice this car. It's drawn to the car's salience or significance, hence its name. When drugs are administered intravenously, they enter the brain rapidly, like a sports car speeding down the highway. This sudden rush is what the salience network picks up on, leading to a heightened sense of euphoria or high. But the salience network isn't just about detecting the high, it's also the mastermind behind the intense craving for drugs. When the salience network becomes repeatedly activated by drug use, it starts to associate the drug with importance, like a traffic controller who starts to prioritize the flashy sports car over other vehicles. So why is this network's activation crucial during intravenous drug administration? Well, the faster the drug hits the brain, the more intensely the salience network responds. This intense response can lead to a stronger addiction, making the high harder to resist and the cravings harder to ignore. The salience network is like the brain's concert director, deciding which sensations or experiences take center stage. Ready for a thrilling journey into the brain's response to various drug delivery methods? Fasten your mental seatbelts because we're about to embark on an exploration of addiction potential and drug administration. Let's dive into the results of a recent clinical trial. A group of pioneering scientists used state-of-the-art imaging techniques, PET and fMRI scans, to observe the brain's responses to different drug delivery methods. Intravenous, inhalation, oral, the brain's response varied with each. Intriguing, isn't it? So what did they find? Well, the study revealed that the brain's salience network, the network that helps us prioritize stimuli, lights up like a Christmas tree during intravenous drug administration. It's like the brain is throwing a party, and the salience network is the guest of honor. Now, this is where things get really interesting. The scientists found that this activation of the salience network correlated with a higher addiction potential. It seems that the route of drug administration can dramatically change the brain's response, influencing how addictive the drug can be. This fascinating study provides a fresh perspective on addiction science. It highlights the intricate interplay between the brain's circuits and drug administration methods, shedding new light on why some people might develop substance use disorders while others might not. The method of drug administration can dramatically alter the brain's response, influencing the potential for addiction. So the next time you think about the brain, remember, it's not just what you take, it's how you take it. How does the conscious experience of drug reward fit into this intricate puzzle? This question leads us into the captivating world of subjective experiences. The study we're discussing today took an innovative approach, combining the quantitative data from brain scans with qualitative data from participants' subjective experiences. They didn't just want to see the brain's response, they wanted to understand how it felt for the individual. The participants in the study were asked to share their real-time experiences during drug administration. These self-reported experiences were then compared with the activity in their salience network. A compelling pattern emerged. When participants reported feelings of euphoria, the brain scans showed heightened activity in the salience network. It was like a light show syncing up with the rhythm of the music. This correlation suggests that the salience network plays a significant role in the conscious experience of drug reward. It's not just about the physical act of taking the drug, it's about how the brain perceives and processes this experience. The Salience network is like the brain's spotlight, illuminating what it considers important and meaningful. This understanding offers a unique perspective on addiction. It highlights the critical role of subjective experiences in addiction and opens up new avenues for potential interventions. After all, if we want to tackle addiction, we need to understand it from all angles. The conscious experience of drug reward is a critical piece of the addiction puzzle, linking brain activity with subjective experiences. As we near the end of this fascinating journey, let's ponder the implications of these findings. The understanding of the Salience network and its role in addiction is like finding a new piece of a puzzle. It's a piece that fits snugly into the intricate image of the brain's complex circuitry, giving us a clearer picture of the mechanisms that underpin substance use disorders. This newfound knowledge holds great promise for the future. It's like a lighthouse guiding us towards new treatments for substance use disorders. Imagine a world where we can target the Salience network, tweaking its activity to help people overcome addiction. It's a tantalizing prospect, isn't it? But our exploration doesn't stop here. The Salience network is just one piece of the puzzle. There are still countless other brain circuits waiting to be discovered and understood. Each one holds the potential to unlock new insights, new treatments, and even new ways of understanding the human experience. So what's next on the horizon for addiction neuroscience? Well, the possibilities are as vast as the brain itself. We could delve deeper into the Salience network, or perhaps explore other networks and their roles in addiction. We might even find ways to integrate this knowledge with other fields like psychology, genetics, or pharmacology. By delving into the intricacies of the Salience network, we open up new possibilities for understanding and treating addiction. We're at the dawn of a new era in neuroscience, and I, for one, can't wait to see where this journey takes us next.